Morning, grade 10s, and welcome to the very easy and exciting section of equations. You are going to be pleased to know that you have been applying equation skills throughout the year. We've done incredibly challenging sections where you've actually been solving equations all along. So this chapter is going to be a quick revision, and now is an opportunity for you to also fill in any gaps that you may have missed throughout the year, because this section forms the foundation of a lot of the skills that you need throughout high school maths. So let's jump straight into it by dealing with equations with fractions. The instruction you are expected to see will be solve for x, or solve for the given variable. And if you see one fraction in the equation, it is wise to turn every term in the equation into a fraction by popping it over number 1. Then you proceed to find an LCD, the process of which I will go over in the examples. And then, because we have an equation, you're allowed to multiply the left-hand side with all the right-hand side of the equation with whatever you choose, as long as what you do to the left, you do to the right. And in order to get rid of a fraction, we multiply each numerator. Remember, numerator is the number at the top, while denominator is the number at the bottom of a fraction. So you multiply each numerator by what is missing in its denominator, and then you can drop the denominator and solve. I'll go through this process now. So let's see. If we're told to solve for x, if 3 over 2x minus a quarter equals 6 over x, first things first, just check. Do we have any whole numbers here? Any numbers that are not fractions that we should perhaps turn into a fraction by dividing by 1? Fortunately not. These are all over a denominator, so we can jump straight into finding our LCD. Now my LCD is 4x. Why? Because you look at the numbers and variables separately. Let's look at the numbers in each denominator. We have a 2 over there, we have a 4, and we have an invisible 1. So 1, 2, and 4 are the numbers that make up our denominators. All you have to do is find the highest common factor into which each number would fit, all right? That's what a highest common factor is. And then you write that down. That highest common factor between 1, 2, and 4 is number 1. Then you look at the variables in your denominator. Luckily, we only have x as a variable in these denominators, so it's pretty straightforward. The highest common factor of the variables, in other words, the highest number into which the other variables would divide without leaving a remainder, would be the x. If there was an x squared, you would choose the variable with the highest power, because it needs to be the number into which the other variables could fit perfectly without remainders. So even though we say lowest common denominator, we're actually finding a highest common factor. Now I'm going to follow this step where I say multiply each numerator by what's missing in the denominator. In other words, I'm asking myself, what do I need to multiply this 2x by in order to obtain the LCD 4x? This 2x needs a times by 2, right? So I am going to multiply this denominator by 2, but what you do at the bottom, you do at the top. And that's why I'm saying 3 times 2 over here. Then we move on to the next term. This number 4, if I were to transform 4 into 4x, what would I multiply by? By an x, right? So that is why I'm taking the negative 1, and I'm multiplying it by an x. Last but not least, if we look at this denominator x, do you agree that you would just need to multiply by 4 in order to transform it into 4x? So all I'm taking is my numerator, and I'm saying 6 times 4. Now I'm being very cheeky. I could have written the denominators in this very line, popped each term 3 times 2 over 4x minus 1 times x over 4x equals 6 times 4 over 4x. You could have kept the denominator there, but then in order to get rid of the denominator, you would multiply by that denominator on both sides in order to cancel it out. So I'm just not wasting any time. I'm cutting to the chase and I'm just dropping the denominator from the get-go. I want to warn you though, do not drop a denominator ever when you are asked to simplify. We only be cheeky, we only take this shortcut when we are solving for equations. So if I'm to simplify now, I see that 3 times 2 gives me 6, and negative 1 times x will give me negative x, and 6 times 4 gives me 24. So I'm just neatening it up, making it look better. And now I'm sure you are frothing at the bit to get x all by itself. Let's keep the negative x on the left-hand side. I've kicked over the 6. It becomes negative. So we have negative x equals 18. And of course, to get x all by itself, beware. I know you all often make this mistake. You think you've solved the equation once you have negative x. But we want positive x as our answer. So you can't stop at saying negative x equals 18. You have to realize that this negative in front of this x is actually an invisible secret little negative 1. So if you were to multiply or divide both sides of this equation by negative 1, you would get x all by itself and you would have x is equal to negative 18. It's as easy as that. So now let's jump into an example where the denominator is perhaps a little bit more complicated, or the numerator has perhaps more than one term. Let's see, how will you handle that? Okay, let's have a look. We need to solve for x if 3 minus x minus 2 over 4 equals 4. Remember the very first bullet point I jotted down on the previous slide? I said turn any given term into a fraction by dividing by 1. So I'm going to take that 3 and I'm going to pop it over 1. I'm going to take this 4 on the right-hand side and pop it over 1. Now we have all sorts of fractions, and so we can find an LCD. Luckily, there are no variables in the denominator, so all we need to do is find the highest common factor for 1 and 4. What number does 1 fit into that 4 also fits into without any remainders? Easy peasy, LCD is 4. Now, the reason I've chosen this as an example is because this numerator right here can cause trouble because there's more than one term in that numerator. So what I need you to write down and highlight this and emphasize it and practice it over and over. When you see a numerator with more than one term at the top of a fraction, and if that numerator is preceded by a minus sign, in other words, the minus is in front of the fraction, and then the numerator has more than one terms, you must put brackets around that numerator because we're going to have to distribute this negative at some stage. Okay, don't forget that. So even if this is a plus sign in front of the fraction and you put a negative in front, you're welcome to do that because it won't change your answer, but it is essential that you do it when there's a minus in front. So now we're going to multiply each numerator by what's missing in the denominator. If I wanted to convert this denominator into a 4, I would have to multiply by 4. What you do at the bottom, you do at the top. So we're now sitting with 3 times 4. This 4 over here, I don't need to convert at all, and so I'm going to just leave it as 4 times 1, but that's really easy. You don't even have to show that you're multiplying by 1. Then this last denominator on the right is a 1, and so what would you have to multiply 1 by in order to turn it into 4? A 4. So what you do at the bottom, you do at the top. And now we neaten things up. So we're going to have 3 times 4 gives us 12. We're dropping the denominator and we're solving a linear equation. Negative 1, there is no, I haven't shown the 1 because the denominator was a 4 already. So now we're going to just have a negative x minus 2 equals 4 times 4, which is 16. Now in our next line, all we have to do is distribute that negative. So we're going to have 12 minus x plus 2 equals 16. and the rest is easy peasy. So that is that. I'm sure you're confident with this. You did this in grade 9. All you have to do is tackle your homework for the day, and the memo will be provided to you. Exercise 4.1 and 4.2. Off you go. Enjoy.